intro to section 4, graphing radical functions of module 4. So radical functions like square root, cube root, fourth root, fifth root, sixth root, any kind of root. You know, here's the domain. As long as it's a type like a square root, all right, if we're dealing with square root, then we can't take the square root of negative, so that's why our domain has to be greater than 0. As we can see from this graph, we don't go to the left. It's not graphed to the left. Okay, and then we can see if we're just looking at what's called the principal square root, so like square root of 16 is 4, that's called the principal square root because it's just a positive when we know that 4 and negative 4. But when it's just a positive, we're looking at called the principal square root. So then our range is above 0. Now this can move up and down, right? You could graph it like this. So the graph does change based on what you add or subtract to this square root function, or it can move left and right as well, depending on what you do on the inside of the square root. Okay, so that's kind of the basic idea of the domain and the range, right? And normally I start at 0, 0, and I just keep on going up as I go to the right, and as I go to the left, I end at 0 there. Okay, so as you kind of look at just different types of square roots, as they move, like I said, left to right, so what happens on the inside of the root, so this negative h in here, I'm subtracting h from x, so that's actually going to move my graph to the left and right, but it's actually the opposite that goes in there. So if I have a negative h, that's actually, so if I have something like x plus 2, square root of that, that's actually going to move left to 1, 2. And then if I have square root of x minus 2, that's actually going to move to the right 2, because now I have to plug in a bigger number to get to my regular. If I want to get to 2, square root of 2, I have to plug in a bigger number than 2. When normally if it's square root of x and I want to plug in 2, I get square root of 2. But in order to do that on this problem, I have to put in something bigger, so that's why it moves 2 to the right. Here, on this one, I'm going to have to put in something smaller to get to 2, right? So I would plug in 0 in order to get to 2, so that's going to move to the left 2. So here's kind of the idea of it. Left and right is on the inside, and then on the outside, a vertical translation, that's on the outside after the square root when I add or subtract a number. So that's just going to move it up if it's positive, and it's going to move it down if it's negative. So this is kind of idea behind it. And then if I'm multiplying anything in front, of the square root in front here, if it's a negative, it's going to flip it and go the other direction and go down instead of up, kind of just like a quadratic that we did. And then if it's anything absolute value of greater than a, so if it's like a 4 or even a negative 4, it's going to stretch it. It's going to make it kind of go higher than it normally is. If it's negative, that just does the same thing, but it flips it over the x-axis. So that's kind of the idea of the transformations you can do on square roots. And that's kind of our idea behind graphing square root functions. And that's how we kind of start off this idea of radical functions. So we'll get into cube roots and that fourth roots later.